Welcome friends. In this module we discuss measures of dispersion part 1, quartile deviation and standard deviation. Dispersion. The average or center of the data may not give the complete picture about the data. Two or more sets of observations may have the same averages, but may differ in the way in which the observations are scattered. For example, consider the following two sets of observations. Number 1, 15, 20, 25, 30, 35. Number 2, 5, 15, 25, 35 and 45. Here the two sets are having the same mean 25. In the first set, the observations are more closely clustered around 25 than that is observed in the second set. The scattering of observation is one of the fundamental characteristics of a set of observations, which is termed as dispersion. Hence, the dispersion is less for the first set of observations than that of the second. For a set of observations with least dispersion, the mean of the set is a good representative of the entire set of observations. If the dispersion is high, the mean cannot be a good representative. It is also to be noted that for a set, if all the observations are same to the mean of that set, the dispersion for that set is 0. Then characteristic of dispersion determines how the average is a good representative of a set of observations. Various methods are available in literature to measure the dispersion of a given set of data. Some important measures of dispersion are 1. Range, 2. Quartile deviation or semi-interquartile range, 3. Standard deviation and 4. Mean deviation. We shall look into the second and third measures in this module. Properties of good measure of dispersion. 1. It should be rigidly defined. 2. It should be simple to understand and to calculate. 3. It should be based on all the observations. 4. It should be capable of further algebraic treatment. 5. It should have sampling stability. 6. It should not be unduly affected by the extreme values. Quartile deviation or semi-interquartile range. Quartile deviation of a set of observation is a measure of dispersion among themselves. Quartile deviation is based on the partition values quartiles. If there are n observations given in the form of raw data, arrange the observations in ascending order of magnitude. The observation coming in the n by 4th and n by 2th and 3 n by 4th position are respectively called the first, second and third quartiles, denoted by Q1, Q2 and Q3. The quartile deviation of the observations is defined as quartile deviation QD equal to Q3 minus Q1 divided by 2. If the observations are given in the form of frequency table, we know the method of finding Q1 and Q3 by the expressions Q3 equal to L3 plus 3 n by 4 minus M3 into C3 by F3 and Q1 equal to L1 plus n by 4 minus M1 into C1 by F1. Problem. Obtain the quartile deviation of the following data: class 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60 and 60 to 70. The corresponding frequencies 5, 9, 20, 31, 18, 11 and 6. Solution. Class 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60 and 60 to 70. The frequencies 5, 9, 20, 31, 18, 11 and 6. Less than cumulative frequency 5, 14, 34, 65, 83, 94 and 100. First quartile Q1 equal to L1 plus n by 4 minus M1 into C1 divided by F1. The n by 4th, that is 25th observation coming in the class 20 to 30, then Q1 equal to 20 plus 100 by 4 minus 14 into 10 divided by 20, that is equal to 25.5. Third quartile Q3 equal to L3 plus 3 n by 4 minus M3 into C3 by F3. The 3 n by 4th, that is 75th observation coming in the class 40 to 50. Then Q3 equal to 40 plus 3 into 100 by 4 minus 65 into 10 divided by 18, that is equal to 45.55. Hence, quartile deviation equal to Q3 minus Q1 by 2, that is equal to 45.55 minus 25.5 divided by 2, that is 10.025. Merits and demerits of quartile deviation. Merits: 1. Quartile deviation is rigidly defined. 2. It can be calculated for data with open-ended classes. Demerits: 1. Quartile deviation not considering all the observations. 2. It is not capable for further algebraic treatment. 3. It is much affected by fluctuation of sampling. Standard deviation (SD). For a set of observations, standard deviation is defined as the square root of the arithmetic mean of the squares of deviation of the observations taken from their arithmetic mean. If x1, x2, etc., xn are the n observations with arithmetic mean x bar, then standard deviation of the observations is defined as SD equal to square root of 1 by n sigma I from 1 to n xi minus x bar square. The square of standard deviation is known as variance. If the observations are given in the form of class and frequency with variable values x1, x2, etc., xn and corresponding frequencies f1, f2, etc., fn and with arithmetic mean x bar, then SD equal to square root of 1 by capital N summation over I fi into xi minus x bar whole square, where capital N equal to f1 plus f2 plus etc. plus fn. Instead of x bar, if we are considering a real number a, then the quantity square root of 1 by capital N summation over I fi into xi minus a the square is called the root mean square deviation or MSD of the observations about the number a. For the observations x1, x2, etc., xn with arithmetic mean x bar, we have standard deviation SD equal to square root of 1 by n summation over I xi minus x bar whole square, that is SD square equal to 1 by n summation over I xi minus x bar whole square. This implies SD square equal to 1 by n summation over I xi square minus 2 xi x bar plus x bar square, that is equal to 1 by n summation over I xi square minus 2 x bar into 1 by n into summation over I xi plus 1 by n summation over I x bar square, that is equal to 1 by n summation over I xi square minus 2 x bar square plus x bar square, that is equal to 1 by n summation over I xi square minus x bar square. Hence, SD equal to square root of 1 by n sigma over I xi square minus x bar square. For the frequency table form of observations, SD equal to square root of 1 by capital N summation over I fi xi square minus x bar square. Shortcut method for standard deviation. If the observations are big numbers, we can use the shortcut method to reduce the calculations involved in finding the standard deviation of the set. Let the observations are given in the form of class and frequency with variable values x1, x2, etc., xn and corresponding frequencies f1, f2, etc., fn and with arithmetic mean x bar. Let us transform the x values to u values so as ui equal to xi minus a divided by c, where a and c are constants as explained in the case of shortcut method for arithmetic mean. Then standard deviation of u values SD of u equal to square root of 1 by capital N sigma over I fi into ui minus u bar the whole square, that is equal to square root of 1 by capital N summation over I fi into xi minus a by c minus of x bar minus a by c the whole square, that is equal to square root of 1 by capital N summation over I fi into xi minus x bar by c the whole square, that is equal to 1 by c into square root of 1 by capital N summation over I fi into xi minus x bar whole square. This implies standard deviation of u equal to 1 by c into standard deviation of x, or standard deviation of x equal to c into standard deviation of u. Note 1. The addition or subtraction of a constant from every observations of a set makes no change in the standard deviation of the set. That is, if the standard deviation of the observations x1, x2, etc., xn is k, then for a constant c, the standard deviation of the values x1 plus c, x2 plus c, etc., xn plus c and x1 minus c, x2 minus c, etc., xn minus c are same to k. 2. Multiplication of every observation by a constant will result in the multiplication of standard deviation also by that number. That is, if the SD of the observations x1, x2, etc., xn is k, then for a constant c, the SD of the values cx1, cx2, etc., cxn is c into k. 3. Division of every observations by a constant will result in the division of SD also by that number. That is, if the SD of the numbers x1, x2, etc., xn is k, then for a constant c, the SD of the values x1 by c, x2 by c, etc., xn by c is k divided by c. Problem. Obtain the standard deviation of the following data: 28, 23, 25, 32, 35, 38, 36, 24, 18, 21. Solution. SD equal to square root of 1 by n summation over I x I minus x bar whole square. The following gives the calculation involved. Here n equal to 10. X values 28, 23, 35, 32, 35, 38, 36, 24, 18. Summation over I x I equal to 280. Therefore, x bar equal to 280 divided by 10, that is equal to 28. X I minus x bar whole square values 0, 25, 9, 16, 49, 100, 64, 16, 100 and 49. Therefore, summation over I x I minus x bar whole square equal to 428. Hence, the standard deviation square root of 1 by n sigma over I x I minus x bar whole square equal to square root of 1 by 10 into 428, that is equal to square root of 42.8, that is 6.542. Problem. Obtain the standard deviation using shortcut method for the following data: class 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70 and 70 to 80. The corresponding frequencies 3, 60, 130, 155, 132, 70, 35 and 15. Solution. By shortcut method, standard deviation of x values equal to c into standard deviation of u values, where ui equal to xi minus a divided by c. Let a equal to 35 and c equal to 10. The calculations are as follows. Classes 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70 and 70 to 80. The mid values of the classes x values 5, 15, 25, 35, 45, 55, 65 and 75. Corresponding frequencies 3, 60, 130, 155, 132, 70, 35 and 15. Capital N equal to 600. Here ui values ui equal to xi minus 35 by 10. They are minus 3, minus 2, minus 1, 0, 1, 2, 3 and 4. Fi ui values minus 9, minus 120, minus 130, 0, 132, 140, 105 and 60. Summation over I Fi ui equal to 178. Fi ui square values 27, 240, 130, 0, 132, 280, 315, 240. Summation over I Fi ui square, that is equal to 1364. Standard deviation of u values, that is equal to square root of 1 by capital N sigma Fi ui square minus u bar square. Here u bar equal to 1 by capital N summation over I Fi ui, that is equal to 1 by 600 into 178, that is 0.2967. Hence, standard deviation of u equal to square root of 1 by 600 into 1364 minus 0.2967 square, that is equal to square root of 2.2733 minus 0.0880, that is equal to 1.4783. Then standard deviation of x value, that is equal to c into standard deviation of u value, that is 10 into 1.4783, that is 14.783. Standard deviation of the combined set of two or more sets of observations. Consider two sets of observations where the first set contains n1 observations and second set contains n2 observations with the mean and standard deviation of the first set are respectively x bar 1 and sigma 1. That of the second set are x bar 2 and sigma 2. Let us combine these two sets of observations. Then the new set contains n1 plus n2 observations with a combined mean x bar. Now, the square of the standard deviation of the combined set, say sigma square, is derived as sigma square equal to 1 by n1 plus n2 into n1 sigma 1 square plus n2 sigma 2 square plus n1 n2 by n1 plus n2 into x bar 1 minus x bar 2 square. Problem. The means and standard deviations of the wages of two groups of employees of a company are given below. Find the standard deviation of the wages of all employees taken together. Company A and B, number of employees 50 and 60, means 113 and 120, standard deviation of wages 6 and 7. Solution. Given n1 equal to 50, n2 equal to 60, x bar 1 equal to 113, x bar 2 equal to 120 and sigma 1 equal to 6, sigma 2 equal to 7. The square of the standard deviation of the combined set sigma square equal to 1 by n1 plus n2 into n1 sigma 1 square plus n2 sigma 2 square plus n1 n2 by n1 plus n2 into x bar 1 minus x bar 2 square, that is equal to 1 by 50 plus 60 into 50 into 6 square plus 60 into 7 square plus 50 into 60 divided by 50 plus 60 into 113 minus 120 square, that is 1 by 110 into 1800 plus 2940 plus 3000 divided by 110 into minus 7 square, that is equal to 55.24. This implies sigma equal to square root of 55.24, that is equal to 7.43. If a set of sample observations are drawn from a population with unknown variance, we find an approximate value or estimate of population variance using sample observations using the expression 1 by n minus 1 into summation over I x I minus x bar square. Hence, we obtain an estimate of the population standard deviation as square root of 1 by n minus 1 summation over I x I minus x bar square. While we are finding the variance of a set of observations, as we know, divide summation over I x I minus x bar whole square by n. But to estimate the variance of the population from where the samples are taken, divide summation over I x I minus x bar whole square by n minus 1. Merits and demerits of standard deviation. Merits: 1. Standard deviation has a well defined formula. 2. It is based on all the observations. 3. It is capable for further algebraic treatment. 4. It is not much affected by fluctuations of sampling. Demerits: 1. It is comparatively difficult to calculate. 2. It gives more weight for extreme items. Some empirical relations. For almost symmetrical distributions, following relationship holds. 1. Quartile deviation QD approximately equal to 2 by 3 into standard deviation SD. 2. Mean plus or minus 1 into standard deviation plus or minus 2 into standard deviation plus or minus 3 into standard deviation includes 61.3 percentage, 95.4 percentage and 99.7 percentage of the observations. One of the fundamental characteristics of a set of observations called dispersion is discussed in this module. Measures of dispersion, quartile deviation and standard deviation are explained. Methods of calculation of these measures are illustrated. Properties of quartile deviation and standard deviation are also included. Before the next session, please try to answer the following questions. Question number 1. Daily caloric intake of 15 healthy females are considered as follows: 20.7, 22.4, 23.1, 23.8, 24.5, 25.3, 25.7, 30.6, 30.6, 33.2, 33.7, 36.6, 37.1, 37.4 and 40.8. Find the mean and standard deviation of daily caloric intake. 2. Frequency distribution of the resting systolic blood pressures for a sample of 35 patients with suppression of blood flow to the heart is given below. Blood pressure 115 to 124, 125 to 134, 135 to 144, 145 to 154, 155 to 164, 165 to 174 and 175 to 184. The corresponding number of patients 4, 5, 5, 7, 5, 4 and 5. Number 1, obtain the mean. Number 2, obtain the standard deviation. Question 3. A study has been conducted for comparing female adolescents who suffer from bulimia to healthy females with similar body compositions and levels of physical activity. Listed below are measures of daily caloric intake recorded in kilocalories per kilogram for sample of adolescents from each group. Bulimic 15.7, 16.2, 16.3, 17.9, 18.3, 17.8, 16.9, 18.7, 18.9, 19.8, 20.6 and 21.9. Healthy 20.6, 22.4, 22.9, 24.1, 24.8, 23.5, 24.2, 25.3, 26.2, 29.5 and 30.2. Compute the standard deviation for each group. Question 4. Find the quartile deviation of the cholesterol level from the following data. Cholesterol level 80 to 119, 120 to 159, 160 to 199, 200 to 239, 240 to 279, 280 to 319, 320 to 359 and 360 to 399. Number of men 10, 40, 102, 85, 33, 13, 4 and 3. Hope you enjoyed the session. See you next time. Until then, goodbye.